Hey everybody, welcome to GIS Day, and thank you to the Maine Geospatial Institute for putting this event on. My name is Izaak Onos. I'm a master's candidate in policy planning and management at the Muskie School of Public Service within the University of Southern Maine. I'm also a recipient of the inaugural Shaw Innovation Fellowship for the project I'm going to be talking about. I have a certification in GIS, and one GIS fact related about me. Back as an undergrad in 2016, I did a GIS project studying a potential bike path in the greater Portland area that actually became a basis for state law that was signed by Governor Janet Mills this summer, LD 1370, an act to turn rails into trails. It was really fun to see that project go into fruition. However, today I'm going to be talking about monitoring long-term vegetation change across Kujataa, South Greenland. I work closely with Dr. Firuza Pavri, the director of the Muskie School and professor of geography, as well as a colleague, Diana Farrell. Greenland is a massive place. It's actually the largest island in the world at 836,000 square miles. That's about 24 times larger than the state of Maine area-wise. It's dominated by an ice sheet. It's quite barren, and not many people live there, only about 57,000. All on the southern coast here. Kujataa is the most southern region, right in this red circle. It's a fascinating, dynamic place. It's a newly designated UNESCO World Heritage Site, largely stemming from some of the best preserved Viking remnants of a 1000 AD settlement from Eric the Red. It has a fairly robust sheep farming population and industry. Due to the UNESCO status, it's increasing in tourism, and there have been rare minerals found in the area. So there's a lot going on. On top of this, Greenland is quite an understudied place, an undervisited place. And this is important to keep in mind in the realms of climate change, because the Arctic is warming at a faster rate than any other region in the world. So there's significant demand to look into places like Kujataa. This project is a 20-year time series of vegetation analysis. Why 20 years? Well, that is a pretty good amount of time. However, also in remote sensing, back in 2000, certain vegetation-related sensors started to get really good and were launched, including one called MODIS, which this project uses. Why use satellite sensors? Well, there's a lot of them, and they're continuously collecting data around the world, and they can provide a unique way of looking at places that are really hard to get to, and in other ways you probably would never be able to research very well. Why a vegetation analysis? Well, vegetation is one of the best land use monitoring techniques. Within the near infrared section of the electromagnetic spectrum, vegetation, green vegetation, shows up really well via reflectance curve. This subsequently can be quantified and can be measured and can be observed over time. So the specific MODIS sensor we're using is MOD 13Q1V006. This provides data generation every 16 days at 250 meter resolution. It already provides something called an NDVI, Normalized Difference Vegetation Index. That is an indicator on a scale of the vigorousness of vegetation, from -1 to +1. Of course, as you get close to +1, that means that it is extremely green. It also provides data for the exact same date each year, pending a leap year where it's shifted by a day. So for this study, we picked a date at the beginning of the growing season, at the height of the growing season, and at the end of the growing season. So not only are we measuring or looking at the NDVI for the same dates each year, but we're looking at each year at different points in the growing season. So there's kind of two levels to it. And we're producing maps like this. So this is Kujataa, and it's dominated by fjords. This gray is nulled out because there's no vegetation there. It's a giant glacier. And the darker the green, the more vigorous the vegetation is. This was captured on July 12th, 2020. The yellow is less vigorous, and it's interesting to see. There's certain places that are much more vigorously green than others. So we can compare the same date of any given year. And this is the big, kind of the bookends for this study of July 2020 and July 2000. And you can see some differences, upon quick glance. There's certain areas along the coastline, like right here, if you compare, it seems like the vegetation's expanded a little bit. It's hard to tell in the very dark green areas how much has changed. And this peninsula looks like there's more going on in 2020 than 2000. However, it's quite exhausting and not the best method to just visually compare the two and take down notes. So I've been playing around with a raster calculator technique, which essentially takes the 2000 data and it is subtracted from the 2020 and produces an image like this. So any pixel that shows up as red means that the NDVI number was higher in 2020 than in 2000. And the blue was a number in a pixel in which 2020 was less than 2000. And it's kind of interesting. You can see near the glaciers, there's a significant increase in NDVI. Areas along the coast, there's less. And then, anywhere you look, there's a lot of red, there's some blue. It adds a level of complexity to this story that we're trying to tell and learn. So for the next steps, I want to further refine this raster calculator technique. Figure out the best intervals. Is 5-year interval good? Is 10-year better? How do we account for years where it's abnormally warm or rainy? Things like that. And figuring out better ways to quantify it as well. Another goal is to potentially expand this study to 20 years earlier as well. We won't be able to have the same quality of data, but it'll be double the amount of time, which will help tell the story better. And of course, hopefully, publish the results, share the results with the locals of Kujataa, and visit. Thank you for taking the time to listen to this.